to this session. But before then, you can see we are having Ascending Grades Online School. It is thrilled to have you of the December holiday 5 weeks program from 11th November up to 12th December. We shall have engagement with our experts in sciences and mathematics. You can inquire through 0757 01 9011. You can also have, you can inquire as early as now. You can also register as early as now to avoid the last minute. So, welcome to our today's discussion where we shall be having a small section on physics paper 1. Some 2 questions, that is question 16 and 17 as part of a part that remained in Nyaga physics paper 1. Therefore, the first question reads, the diagram in the figure below shows an experiment to investigate the relationship between volume and temperature of a fixed mass of a gas at constant pressure. You can look at the diagram well, where we have a thermometer, we have a stirrer, we have concentrated sulfuric 6 acid, we have dry air, and I think this one is a tube. We have presence of it, we are having water bath. So you are asked which measurements are taken in the above experiment. What can be measured? So if you look at this one, the first point which is very clear is that you can see the instrument, which is thermometer, and this one is used to measure the temperature. So temperature is being measured in this case. Then number 2, what is supposed to be measured? If you look at this concentrated sulfuric 6 acid, is just giving a trapped dry air here. So the other thing that you can measure is the change or variation in the height of the dry air. So we have height or the length or the volume of the dry air or the volume of the dry air. Then you can move forward. So which law, or state the law being investigated in the above experiment? This will be the Charles law. Something is held constant, Charles law. I think it is pressure, but we have variation between temperature and volume. That is Charles law. Then you are told, describe how the experiment above is used to verify the law. We have to narrate this one. We have to narrate. So record the initial temperature, and the corresponding length, and this length is the one that is giving us the volume of air column. Then water is heated. You are supposed to heat the water bath. Is heated, and new height of air column is recorded, and corresponding temperature reading. So repeat the same process. Repeat for several values. And tabulate. Then plot a graph of volume against temperature. Then now our expectation will be, it is a straight line. It is a straight line cut in temperature, axis at negative 273 degrees. Sorry, this is supposed to be Kelvin. At negative 273. Then this shows that volume is directly proportional to temperature. When pressure is every constant. Then give or state one assumption made in this experiment. Pressure shall remain constant. Pressure remains constant. So that is one assumption. Then number 2, during the recording of the temperature, we expect uniform distribution of it. So there will be uniform distribution of it. There will be uniform distribution of it. State the condition necessary for a body to float. State the condition necessary for a body to float. Then the weight of fluid displaced. Weight of the fluid displaced by a body is equal to the weight of the body. Like that. A certain solid of volume 50 cubic centimeters displaces 10 cubic centimeters of kerosene of density 800 kilograms per cubic meters when floating. Determine the density of the solid. We have to take some few steps here. So the first thing we need to get is the weight of the kerosene. So what will be the weight of the kerosene? This will be given by volume times density times G. So what is the volume of the kerosene? that is displaced, it is 10 cubic centimeters. So if we work in SI units, then we divide by a million. So it's like saying 10 times 10 raised to power negative 6 times 800 times g of 10. This will give us 0.08 newtons, like that. Now, since the weight of kerosene must be equivalent to the weight of the solid, then we can get the mass of the solid. So NP, allow me just put it, the weight of kerosene displaced is equals to weight of solid. Therefore, the weight of the solids becomes 0.08 newtons. Now, from the formula of weight is equals to mass times g, then we can get the mass of the solid. Therefore, the mass of solids will be weight over g, and this is this will be our 0.08 newtons divided by 10, and this will lead us to 0.008 kg, or this one is equivalent to 8 grams. So if you multiply 0.08 times 1,000, then you are going to get 8 grams. So now, our question is asking, determine the density of the solid. So now, we have now the mass of solids as 8 grams, the volume of solids as 50 cubic centimeters. Then, what will be the density? So our density will be given by mass over volume, and this gives us 8 grams over 50, which is equivalent to 0.16 grams per cubic centimeters. If you convert that density to SI units, then it shall become 160 kilograms per cubic meters the moment we multiply by 1,000. We have our last question, which is question 17. Even though the graph may not be so clear, but you are told the graph below was obtained when an experiment to investigate the variation of the centripetal force F with radius R. So this is radius R, and as you can see from very far, it is given in meters. So this is the graph, you can see it. Then you are told that if from the graph determine the angular velocity omega when the body given m is equals to, in short, the body that is being investigated over here is of 100 grams, and we have this equation: F is equals to m omega squared r plus c. So our equation here is equals to F m squared, that is omega squared, r plus c, and we are told that c is a constant. So if you study very well from the graph and you relate this equation to y is equals to m x plus c, then our y intercept is clearly from the screen. That gives us also the constants. Then our m, which is supposed to be the gradient, but before the gradient, let's establish the value or the contents of x-axis. So in our x-axis, we can see we are given the r. So we can say our r stands for x, and then m omega squared stands for our gradient. So our slope, we can say, is equals to m omega squared. So it is going to give us the slope. So the first thing that we are being asked, you are so determine the angular velocity omega. So now the first thing we need to get is the gradient or the slope. So from my case, you have to identify the points where you need to establish your gradient from. So mine, I will use these 2 points. So allow me indicate. So these are my 2 marked points. From your side, it is my hope that it is super clear. Super clear. It is very super clear. Then I'll pick the points from here and here. So let me now get the slope. Our slope will be given by change in y over change in x. So I'll pick 0.6 is equals to 0.6 minus the point here. From our scaling, if this is 1 and this is 2, in between we shall be having I've drawn it wrongly, so allow me reschedule that part. And I have this new value here. Like that. So this becomes my next point, which is 0.1. Then you divide through by, this will be 0.5 minus, we need to look at the scale very well. We need to look at the scale very well. This is 0.5 here, 0.5. Sorry, 0.05. Then we shall be at the second point. If it is very clear, then we shall be at the second point here. And this will be this part now. This will be 0.07 from the scale that we are having over there. So this will lead us to 0.5 divided by 0.43, giving us 11.63. Then remember, from this formula we say that our slope is supposed to give us m omega squared. Therefore our slope, which is 11.63, shall be equivalent to, let me just write here, slope is equals to m omega squared. Our mass here is of 100 grams. You convert it into SI unit, which is 0.1, then times omega squared. So omega squared is the same as 11.63 divided by 0.1, and this will lead us to 116.3. That is our omega squared. So our omega will be the square root of 116.3, and this will leave us with 10.78 rads per second, like that. So now we have solved that. Then part B, we are told that a stone of mass 0.2 kg tied to a string is whirled in a horizontal radius 1 meter at a constant speed of 3 meters per second. Then you are asked, what will be the angular velocity of the stone? Angular velocity can be given by the velocity of a radius, which is equivalent to 3 divided by 1, and you get 3 meters per second. Then Roman 2, the tension in the string. We know that from the formula, force is equals to m omega squared r. We can also equate the force also to be T is equals to m omega squared r, because tension is also another form of force, tensional force. Therefore our mass here is 0.2, so our T will be 0.2 kg. You multiply by omega squared, which will be 3, you square it, times a radius of 1, and this will lead us to 1.8 newtons, a tensional force of 1.8 newtons. A reminder, Ascending Grades Online School is thrilled to have you on board for the December all-day program. We shall be having 5 weeks from 11th November to 12th December, engagement in sciences and mathematics. Enroll through 0757 0190 11. Refer this one to a friend. If you're a parent, kindly don't allow this program to be off your desk. Ensure it is within your mandate, within your desk. We are here, and our promise is that we help in elevating your sons or daughters' grades. Elevate your futures. Elevate your futures. So we have the last bit. The number of revolution makes in 1 minute. So we record the omega, or the angular velocity, as 3, and this one we can get it from or for us to get the number of revolutions in 1 minute, then we shall say we shall engage the omega over the total, or in one that is in one complete revolution. Then you multiply by the number of seconds in 1 minute. So 2 pi is equals to 1 revolution. So now, what about 3 rads per second? This will be the same as that is 3 divided by 2 pi. Then we multiply by the 1 minute, that is 60 seconds. So this one will take 3 out of 2 pi times 60, and we shall have 28.65 revolutions per minute. So thank you so much. My contacts 0757 019011. You can always contact that number. You can WhatsApp it. We are here at your service. Still a good reminder, Ascending Grace Online School is thrilled to have you on board over the December all-day program. 5 weeks non-stop, 11th November up to 12th in December. Sciences and mathematics. Call that number on your screen and help us have your child on board. Then we shall provide good impact, academic or wise. Thank you so much. May God bless you.